Okay, so in this video I'm going to show you how to test your engine mounts using the NVH toolkit made by Picoscope. So I have the NVH interface right here. NVH stands for noise, vibration, and harshness. We're going to be measuring vibrations in this video. So I've got the 3 BNC cables plugged into my Picoscope. My Picoscope is enabled right now to do NVH, and you have to do that before this will work. The other side of my interface has an accelerometer plugged into it, and that accelerometer looks like this. This accelerometer measures 3 axes of vibration, X, Y, and Z, and it has a magnetic base on the bottom that we're going to hook onto our frame and our engine, and I'll show you how to do that in a minute. It comes covered with this washer and a chunk of plastic to protect that magnet, so make sure you remove that before you do the test. Right, the other thing we've done is we've plugged in a pass-through device into the OBD2 port. We're using a Cardac M for this. And then on the laptop, I will show you how to connect to that Cardac M in just a minute. All right, so here on the laptop, in order to connect to the Cardac M, you have to have this J2534 toolbox downloaded from Drew Technologies website. And then once you do that, you will select the Cardac M, you'll input the serial number that's on the back of your tool, and then you can see right here that we are connected and communicating. Once you've done that, then you can go ahead and open the Pico Diagnostic software, and you'll be ready to set up for the test. Okay, so here's the Pico Diagnostic software. On the left-hand side, we're going to select this tab NVH. We're going to start a new session. For a new test, it says. And then we're going to tell it which pass-through device we're using, which is selected right there, the J2534. We've connected to the Cardac M successfully. Now we're going to select a few options for what type of vehicle we're testing. This is a V8, 4-wheel drive. That is the differential ratio for this vehicle. It's already saved the settings from the last time I did this. Those are the stock tire sizes. We're going to use a 3-channel accelerometer. And then here's our setup. You can see that it's already communicating. And this is one option for an accelerometer. You could put it on the seat rail if you're doing vibrations as felt by the driver, but we're going to be doing something a little bit different here. And we'll finish that off. Okay, so now that we're all set up in our software, I'm going to show you where to hook up the accelerometer, and we'll come back and look at our vibrations. Okay, so we've got our accelerometer ready. We've removed that plastic piece in the washer, and we've got it magnetized to the side of the engine first. We're going to measure how many vibrations or how strong the vibrations are on the engine itself. And then we're going to move the accelerometer over to the frame on the other side of the engine mount and compare. If they are drastically reduced, then we know our engine mount's working. Okay, if it's not reducing those vibrations, then we probably need to replace the engine mount. Okay, now you don't need to worry about which direction the accelerometer is facing for this test. You just need to make sure that when you move it from the engine to the frame that you keep it the same. All right, so here's the engine, then we're going to move it to the frame. Let's take a look at our vibrations on the screen. Alright, so we took a little recording of about 25 seconds of what was happening when we had the accelerometer on the side of the engine and then when we moved it to the frame. So right here in this section of our recording, this is all on the engine. This noise we're going to ignore because this is just me moving the accelerometer. And then right here is after I hooked it to the frame on the other side of that engine mount. So I'm going to click play so you can see what the vibration looks like. There's a lot of E1. E4 is really high. We'll talk about that in just a second. We'll ignore this part because this is just me moving it around. And then right here is after I hooked it to the frame. We still see the E1 and the E4, but they're so much lower than they were before. So just based on that, we know that the engine mount is doing a good job of getting rid of those engine vibrations so that the driver and passengers of the car don't feel them. Okay, but let's go back real quick to the beginning so I can explain to you these engine vibrations. E stands for engine, and these are orders, right? So it's a first order vibration, second order vibration, there's no third order vibrations here, and then there's a fourth order vibration. First, second, third, and fourth orders, what that means is this E1 is happening at the same frequency or speed as the engine's crankshaft. This vibration would be happening at twice the speed, and this one's happening 4 times. So 4 times per rotation of the crankshaft, we have a vibration. Since this is a V8, it's normal to have really high E4 vibrations because there's 4 cylinders firing for every rotation of that crankshaft. Okay, so if it was a V6, you'd have a lot of E3s. If it was a 4-cylinder, you'd have a lot of E2s. And then you're always going to have some E1s because there's going to be vibration from that crankshaft rotating, and this is happening at the same speed as that. So hopefully that helps you understand. But this is a really quick and easy test to verify that your engine mounts are working right, especially if you can't visibly tell if they're bad. And that is how you use and set up the NVH toolkit.